Good afternoon. This is our first new video lesson on the early chapters. We are, of course, beginning with minerals. So those of you that made it to the first day of class, which were most of you, we briefly looked at some of the minerals and uses for them. And there are several slides in between the uses for minerals and definition of a mineral that I want you to read on your own. Actually, I want you to read the whole PowerPoint on your own when you have time, and we are going to film lessons on the things that are most important. So we're going to start with definition of a mineral. Not just anything can be a mineral. So a mineral must be solid. For example, ice is a mineral, but when it melts, it's no longer a mineral. Then it is water, the universal solvent, but can't be a mineral anymore. Minerals must be naturally occurring. So cubic zirconia, which is a man-made diamond, while it is a gemstone and pretty, it is not a mineral because it is not naturally occurring. Minerals must also have a defined chemical composition. I have 3 examples up here, and these are, as far as I can remember, these are the only mineral formulas I'm going to ask you to know for your first exam. Quartz, which is one of the 2 dominant minerals in the continental crust. We talked about quartz in class, used for making glass. Quartz is SiO2, silica and oxygen. Pyrite, there's a nickname for pyrite. Can you guys remember what it is? If you said fool's gold, you're all correct. Pyrite is FeS2, iron sulfide. And then there's calcite, which we talked about in class. Calcite is in the medicine Tums, and calcite is CaCO3, calcium carbonate. So defined composition. Minerals must also have a crystalline structure, sometimes referred to as a crystal habit. So some examples would be the quartz crystal I showed you in class that was a 6-sided hexagonal prism. Another example would be the calcite crystal I showed you guys in class that had a rhombohedron shape. Minerals must be inorganic. Okay, this means that the mineral itself was never alive. And this will get tricky when we get to sedimentary rocks and we talk more about limestones. So limestones are made of calcite. Calcite is a mineral and it's inorganic. But sometimes living creatures can cause minerals to precipitate. So you'll see on your slides there'll be a question asking you about sugar. Think about sugar crystals. Would sugar be a mineral? It's solid, it's naturally occurring, it's got a defined chemical composition. C6H12O6, I believe, is the chemical formula for glucose. But sugar is an organic molecule, so sugar cannot be a mineral. The inorganic forms of carbon are listed on the slide in the PowerPoint. And one that I had to learn in school and doesn't make it into the textbooks is homogeneous, which just means that the mineral is the same all throughout. So definition of a mineral is something that will be on your first exam. We're now going to move around the room. And next we are going to take a look at the 2 dominant minerals in the continental crust. I may have mentioned this in some of our classes this week. The 2 dominant minerals in the continental crust are feldspar and quartz, which are also both very useful minerals, and they are commonly found in granite. And granite is the rock type making up the continental crust. I also might ask you, and I might have to adjust the iris. Okay, that's a little bit better. It was a little too bright, perhaps. Okay, so the dominant mineral in the mantle is olivine. The mantle, as you might remember from your 9th grade earth science class, is the thickest layer of planet Earth, and it's made of olivine. Olivine is a green mineral, and hopefully next week I'm going to have some more minerals out to hold up and show you guys, and I'll show you the olivine. It's a nice olive green color. All right, now we're going to move around again. And we will now take a look at how do minerals form. Okay, we're going to have 5 means by which minerals form, and we're going to have an example for each one. This is also on a PowerPoint. A lot of this is, but if it's extra important, I'm going to put it on the board and make a video lesson about it just to emphasize. So how do minerals form? One common way is solidification from an igneous melt. What do we mean by an igneous melt? Well, we mean, of course, magma and lava. Remember that magma is molten rock below ground and lava is molten rock at the surface. Examples of common minerals that will grow out of an igneous melt are things like quartz, feldspars, and micas. Remember muscovite mica and biotite mica we looked at in class? And they're common in granite, and granite is a common intrusive igneous rock. We'll learn more about igneous rocks after we're finished with minerals. Precipitation from an aqueous solution. Aqueous solution means a water solution, so this could be groundwater or surface water. Examples of minerals that grow out of a water solution are halite, NaCl, table salt, and gypsum, calcium sulfate. I think for most classes, I did have a chance to hold up the halite and the gypsum and let you guys get a look at them from a distance. Remember that halite is table salt, gypsum is what makes up sheetrock or wallboard. Number 3, solid state diffusion, which is another word for metamorphism. So we'll learn about metamorphic rocks later in the semester, after we've had one exam and after we've talked about sedimentary rocks. So common minerals that form as a result of solid state diffusion are things like garnets, which is the gemstone for January, I believe, and the micas, the muscovite and the biotite mica that we looked at in class. We're now going to scoot over a little bit, and I might have to, do I have to white balance again? Nope, I don't. Okay, good. So number 4, still on how do minerals form. Biomineralization. What does bio refer to? Life, of course, like biology, study of life. So biomineralization, what happens here is that living creatures like shellfish, okay, so think oysters and clams, for example, cause minerals to grow or precipitate out of the water solution. Hi, I'm filming. Okay, and I took my mask off so that my microphone will pick it up. Is it going to bother you that my mask is off?
No.
All right.
I'm just dropping off screen.
Okay, that's cool. Okay, so, all right, back to where we were. Okay, so biomineralization. Again, think oysters and clams are great examples. So they take ions from the seawater, calcium, carbon, and oxygen ions from the seawater, and they cause minerals to grow or precipitate around their bodies, making a shell. So, of course, our best example here is the mineral calcite, which is making up our limestones. We will learn more about limestones after the first exam. Number 5 is one of my favorites, fumarolic mineralization. Fumaroles, we're talking volcanic vents. So imagine pictures that you've seen or video of Yellowstone National Park or the volcanoes out in the Hawaiian Islands, Big Island of Hawaii, like Kilauea. Fumaroles, volcanic vents. What happens here is that minerals such as sulfur are dissolved in the gases. When the gases are beneath the ground and they're hot, say at one of those geysers like Old Faithful, you have sulfur, which is both an element and a mineral, dissolved in the gases. But when the gases escape at the vent, they cool very quickly at the kind of temperatures we have at Earth's surface. And then the gases cannot hold the mineral in solution anymore, and sulfur grows around the vent. I believe I held up the sulfur in class for us to look at this week. We're going to move again. We're going to move a chair out of my way. All right, we are now going to look at classes of minerals. Yes, there are several slides in between all of this that we've done, several PowerPoint slides, but again, the things that are not so important, I'm going to leave up to you guys to read on your own time. Classes of minerals. There are several, and what I have on the board, I'm leaving out a couple of classes that I generally don't put on the exam. So we'll say that the most important classes of minerals and how they're formed and what they're made of and examples are right here on the board. So we're going to start with native elements. What this means is that, well, it's a class of mineral that consists of just one element only. So it's not a compound. Great examples are diamond, graphite, gold, silver, sulfur. Diamond and graphite, by the way, both have the same chemical formula, C, carbon, but they're very different. Diamond is the hardest naturally occurring substance known to man. and graphite is very, very soft. Graphite is number 1 on Mohs scale of hardness, diamond is 10. So they're very different, but they're made of the same element. So why are they so different? It has to do with where they form, and you will find a quick discussion on that in the PowerPoints. Number 2, sulfides. SULF is your clue that sulfur is in there somewhere. Sulfides consist of metal, some kind of metal, and sulfur, of course. So great examples here are pyrite, fool's gold, FeS2, iron sulfide. I held up some of this in class, and then galena, which I haven't seen yet, but I will hopefully get to the other minerals to show you next week. Galena is lead sulfide, PBS. Then we have the sulfates. Again, you have SULF in the name, so sulfur's in there somewhere. It's in the form of the sulfate anion, which is SO4 with a -2 charge. So in case of the sulfates, that sulfate anion bonds with a metal to give you sulfate minerals. By the way, the classes of minerals, how they're classified by their anion groups. And in this case, it's a sulfate anion. Our examples would be, well, gypsum, which is calcium sulfate, CaSO4, with some water in the crystal lattice, and we looked at some gypsum in class this week. Moving over, number 4, the halides. So the halides are going to consist of some kind of metal and one of a couple of halogen anions. So chlorine and fluorine are halogen elements. And if you'll notice here, I have Cl-1 and Fl-1 written down. How we would read those would be chloride anion or the fluoride anion. And as you might guess, ionic bonding is going to be in here. Bonding, chemical bonding, you will read about on the PowerPoints. I may go over to the screen and film a little bit of that quickly in a few minutes. Anyway, our best example of the halides, oh, I forgot to write it down, so I'll just say it in words. Remember halite, NaCl, that big chunk of table salt that I held up and showed you guys? Halite is a great example of a halide. Then we have carbonates. So carbonates consist of some kind of metal and the carbonate anion. So the carbonate anion is CO3 with a -2 charge. There's also a radical carbonate anion with a different charge, but we'll leave that alone. So of course your best example here would be calcite, which is CaCO3 in the medicine Tums, if you'll remember. All right, moving on. Our 5th group of minerals, or class of minerals, that we will focus on for this class are called the silicates. So the silicates consist of metal, some kind of metal, and what we call the silicate tetrahedra, SiO4 with a -4 charge. So the silicate tetrahedra, imagine one small silica atom surrounded by 4 larger oxygen atoms. How do we draw that in class? Well, we make what I have on the board here. How do you draw that in your notebook? Make a triangle first, and then you're going to go from each of the 3 corners with dashed lines to the center. The dashed lines will meet in the center. So how does this drawing represent the silicate tetrahedra? Well, each of the 3 corners is an oxygen atom. Where the dashed lines come together in the background is an oxygen atom to give you 4, and then we just assume and know that the silica is hidden in there. So I like to refer to this as the Citgo triangle. Citgo gas stations that you'll see out on the road, the sign has something similar to this. Now silicates are very important. They are the most abundant mineral group. There are several classes of silicates. Now, we will leave the classes of silicates alone for a future video. I can't film too many minutes at a time or it will take way too long to upload to YouTube. So I'm going to shut the camera off and then we'll transition over to the PowerPoint slides and I'll film just a little bit more. So for this week, you'll have a couple of short videos to watch and take notes on.